My name's Al Kovalik, and I'm the session chair. So who is this man? What is that? Isaac Newton, indeed. Thank you, Tom. So we'll prove that it's Isaac Newton. And he's the first guy in 1680 to actually come up with the idea of a mass 1, me or you, being attracted to an Earth mass 2. And he came up with this equation. It's totally world famous. It still stands to this day, of course, except for relativistic speeds. And that force, maybe by the graviton, is attracting right now all of us to the Earth. How beautiful that can be. By analogy, by illustration, by simile, let's look at this one. Mass 1, in this case, by analogy, are media systems of all kinds of media systems. Take your pick. Map it into your world. Mass 2, which is immense, like the Earth, is the attraction of the cloud. What actually attracts the cloud? What are these attractors? Well, they're not gravitons. They're things like services, agility, scalability, capacity, trust, access. These create this horrendous mass 2 of the cloud. And that's what this session's about. It's about why we cannot avoid these attractors, and why your business, whether you're a vendor, an end user, is going to be affected by this. So let's start with our first talk. You can bring that first slide up. This is Shailendra Mathur from Avid. He is the chief architect of Avid's products, and he's in the office of the CTO. And Gerald, too, from Microsoft, and he's a senior program manager for Azure Storage. They're going to do a little tag team here. Let's get them started on cloud transition patterns for media enterprises.
Thank you, Al. Right, so I don't think we can avoid this cloud thing, right? So what we're really here to talk about, Gerald and I, are making it more specific to our media industry. So that's basically the talk here. So we're going to be discussing some of the cloud transition patterns that we're observing around the industry. And we'll start off by actually talking about the current product infrastructure. So just going to form the problem statement first. What is it that we're talking about? What type of infrastructure are we talking about porting? Once that's done, Gerald's actually going to go through some of the cloud definitions. There are data centers, there are private clouds, public clouds, all of these things. So when we're talking with different media enterprises, we have to pay attention because they may mean something different when they say the term cloud. So that's what he's going to talk about. I'm going to come back and talk about a software platform that actually connects them, provides common hosting, and it's not just about the Azure or AWS platform, but other media-specific platform concepts and actually how they help. So let's just jump into the problem statement here. First of all, cloud adoption in the media enterprise has taken off, right? I mean, it's people are already doing it. But however, the media enterprise is big because there's music production, there's episodic television, there's film. So there are multiple segments. There's broadcast and film. So the pipelines can be actually very different between them. And hence, the infrastructure can also differ between them. And let's just and even within each segment, the cloud adoption can differ based on how easy it is or how amenable the cloud is, the cloud technologies are for that particular part of the value chain. So just as an example, in film productions, dailies or any transcoding or for OTT distributions, a lot of these things very amenable to the cloud right now. A lot of them are software processes. Doesn't mean it's easy. I mean, but it is, the infrastructure is set up for that type of work. On the broadcast side, again, same thing. Any OTT distribution, again, that's where the cloud has been coming in. One area that we're focusing on is, let's call it the in-studio post, the post-production environment. And what we decided to do is pick a broadcast post environment just because it actually brings in multiple infrastructure elements. So it forms a very a bit of a challenging environment there. And that's why we'll take that as the comparison and see how that maps to the cloud infrastructure. So that's the in-studio post, and as I said, contribution, production, right now, even that's a bit of a challenge right now because of the very high bandwidth, some of the high bandwidth captures that need to take place. Distribution is much better covered, even in this environment. So a typical post-production. Again, I'll lay out the problem statement here, talk about the different applications and the infrastructure currently involved, but I'll also talk about it in terms of network, compute, and storage. Those are the three elements primarily, and also the client applications, how you actually interact with them, and how that will set out the problem statement that way, look at how that will transition to the cloud. What are the patterns that help there? So a typical environment in studio, you got your baseband ingest, file-based ingest, right? Baseband ingest, in terms of compute, mostly CPU-based, but yet because of the SDI connectivity and also some of the hardware encoding, multi-channel encoding, FPGA hardware actually comes in there too. So that sets out one problem statement there. Of course, now even on premises in the machine room, we can have IP-based captures going there too. File-based, much easier. Right? It is basically file camera raw images coming in, being transcoded. Where does it all make it? It makes it into a storage environment, but I'm going to address the shared storage environment because in a post-production environment, you got multiple editors, you have multiple other client workstations working off the same material. And whenever this happens, any of the asset metadata goes into the asset management systems. So again, a lot of those are already network connected. So even from your baseband capture to the shared storage, that's a network connected environment already. So CPUs, CPU-based COTS hardware actually just works just fine. In terms of storage, you got three types. The real-time storage, which is going to be serving up multiple editing clients. Nearline storage for just parking some of the material. Archive storage. So there are different tiers of storage that becomes that are used over there. And even before I go to the upper client layer, you have the playout side. Assume things are finished, playout distribution, so some of it is file-based distribution. So this is not final distribution. This is sort of the masters that you're creating before it actually goes into the distribution chain. So file-based, again, CPU-based hardware, network-based connectivity to storage is enough. But then in the broadcast world, you have graphics, you have branding. That's where some of the more dedicated servers come into play, some of the appliances that have GPUs come into play. And the same as ingest, SDI and IP actually are starting to play a role there. And SDI still requires some of the FPGA-based hardware to perform some of the playout. So this is probably, the bottom layer is probably the most resource or infrastructure intensive problem that we're trying to solve. However, we're creatives. This is the media world. The creatives are working through their clients. So in the post-production environment, that becomes a very important part. A lot of interaction, so multiple editors working off the same shared storage. Right? That's one of the, as you move to the cloud, we got to solve that problem. You have to solve the problem of display. How are you actually displaying the content? How are you interacting with that? Whether it's an audio DAW, a color correction color correction station, a controller. So if something is running in a cloud remotely, your controllers are still local to you, and you need connectivity for these interactions. So that sets out some of the problem statements too. So this is not just about showing the screens, but it's actually how you're interacting with the screens as well. And again, in terms of the network compute and storage requirements, storage, you could be working off the shared storage, IP connected, network connected. But in terms of compute, of course, graphics, color correction, VFX brings in GPU-based programming. So GPU-based infrastructure becomes important there too. And remember, these client workstations can do, like especially the DAW is capturing directly on the workstations. Right, so for audio, most of the captures are still taking place using DAWs that are local to you. So this kind of hopefully paints the picture of, well, this is our problem statement. This is the infrastructure that we're talking about. So when we say, let's move everything to the cloud, we got to analyze each bit and see which one moves to what. And that's where some of the cloud patterns actually come in. So that's where I'll hand over to Gerald, and he's going to talk about the different cloud hosting models, and I'll come back afterwards.
Thanks. So we wanted to show this slide, and we really wanted to get everyone level set on the different essential names of cloud deployments. So from here, you can see we have 4 off-premise and 2 on-premise names. You have public cloud, private cloud, community cloud, local cloud, and then for on-premise, you have your machine room data center, and you have on-premise private cloud. Some of this is going to be new, and some of this is going to be old, but we wanted to make sure that everyone was level set in terms of what each one of these were. So that's the conversation I'm going to be having. So I'm going to start with machine rooms and data center, and this is what people are most typical and most used to already. This is a studio or shared dedicated space with dedicated bare metal servers. And these workstations have specialized SDI and IP protocol video and dedicated audio cabling. You know, a lot of these have short distance mixers, edit controllers, color correct, like Shailendra was saying. And they typically have KVM switches to access multiple workstations from the same keyboard, video, and mouse. From here, we look at the virtualized data center, which is on-prem. And the only main difference here is that you're moving away from that studio space into probably a machine room or something that is located 100 yards or 200 yards or in the next building over. You still have that high-performance connectivity. The big difference here is that now it's a co-located space. Your other departments and work groups are using the same network ingress and egress of this. Obviously, multi-tenant services and virtual machines are really common in this environment, and you start moving away from some of that dedicated cabling. IP-based interconnects play a much larger role, so you move from SDI communications to IP converters, and instead of having KVMs, you use VDI remote desktop and replacements from there. So instead of going down to the on-premise private cloud from there, I'm actually going to start talking about the off-premise local cloud, because it's a natural transition from that virtualized on-premise data center to the off-premise local cloud. The infrastructure management tools are still used and deploying those same VMs. And you still have, the biggest difference is that you now have this high bandwidth network link that connects your local cloud to your on-premise folks, right? Some people ask, okay, well, what's the difference between the local and the private cloud? And the biggest difference that, that we're defining here is that if you see the local cloud has multiple customers, while the private cloud is a single customer instance, right? Your private cloud is typically owned and operated by either the media enterprise themselves, or it's operated by a third party, but it's in geographical proximity where that high bandwidth network link like really lives in the like sub-millisecond kind of timelines. And your local cloud is your co-located data centers. You're usually sharing the facility. You're isolated via software or physical cages, but you're not, and the biggest advantage of that is the reduced cost due to the shared infrastructure. Community cloud is the next one, and it's a variant of the shared infrastructure between several organizations that have similar concerns. And so there's specific products usually in this community cloud, such as remote editing or asset management, or specific security compliant workflows. And so we consider this really the SaaS model approach to the cloud. Next, we're going to talk about is the public cloud. So the public cloud, we consider this standard multi-tenant shared infrastructure. The big advantages, obviously, to the media customers is the access and presence of multiple regions. As you can see from here, Microsoft has 36 regions around the world with plans for another 6. So that distribution of data centers allows for geographically distributed enterprises to work in a consistent fashion. This geographical distribution also allows for collaboration use cases, and one great example of this is Avid's use of Azure's public cloud for their Pro Tools artists to collaborate over various geographies. And then finally, we're going to be talking about the on-premise private cloud. So this is completely new probably to most of you guys, and this is Azure Stack. Azure Stack is something that Microsoft created because we believe that the traditional data center was not going away, but changing to a more hybrid model. What Azure Stack does is it allows for common cloud software implementation shared between on-premise and cloud-based deployments. Both VM appliance and cloud-native microservices can run in this environment, and for products developed against a cloud-native framework, the development time and complexity of dealing with different past frameworks gets completely eliminated. So what I'm saying here is really, if you think about how you're developing your tools today, you're developing them in a on-premise, and I have developed for the cloud. I have different APIs, I have different calls for both. With Azure Stack, you completely eliminate that, and you're really reducing the time to get your product in a scalable, deployable fashion, right? The simplification of these resources and accounting of the data center is comprised of scale units with Azure Stack. And the scale units use the same hardware and infrastructure services, and they're horizontally scaled by increasing those scale units. Azure Stack manages the scale units in your local region, and it's also capable of elasticity beyond that region by binding together resources from different regions or from the public cloud. So the biggest thing about Azure Stack is that it's crucial in critical regions where customers aren't able to get that high bandwidth network connection that I was talking about, but they still want to be able to leverage the power of the cloud. So now you can have an Azure Stack sitting in a region where Azure isn't necessarily located, but you can use that and then connect that to the public cloud and scale that way. So with that, I'm going to turn it back over to Shailendra.
Cool. Thanks, Gerald. So one of the advantages of this whole Azure Stack model, apart from the connectivity to the public cloud, is also the fact that multiple regions can be aggregated together. Why do that? Because what's the promise of the cloud? It's basically resource pooling, elasticity, on-demand usage. But then when those factors come in, just a bare metal environment does not work, right? So you do have to move your media services and applications to virtualization methods. What are the two common virtualization methods? I'm sure, this has been around for a long time, so I'm just going to talk about it with respect to the media services. But just as a reference on the bare metal side, this is what we're used to, where any of custom hardware, custom IP or SDI interfaces can apply. And if you do want to distribute your processing and have some sort of resource pooling, multiple processes taking place, it's your application that needs to control that. You need to orchestrate that just within the resources given to you. But in the virtualized machine case, basically now you can actually bring in your traditional application. There are multiple services that have been built with like thousands of years of investment, person-year investment in the code that's put in, but it's all working as a monolith, whether it's a creative tool or whether it's a service. But yet virtualization is what letting us just lift and shift that in here and just into a cloud environment, into a virtualized environment. The resource usage over there basically comes down to the hypervisor, where the hypervisor allows you to virtualize in terms of the driver stack. So that means that if you have special FPGA-based hardware, unless that's virtualized, whether it's in a local data center or in a public cloud, may not work. But yet IP-based network virtualization already exists. So that's why the IP features actually really help us bring that together in the virtualization world. One cost is the fact that you're taking up, for each VM, you're taking up a full operating system. But that's the benefit, because as far as the applications and services are concerned, they don't see a difference between running on a workstation and a VM. But the cost is that you're bringing up, you have multiple licenses of the same OS running. And that's where containerization comes in, where you're splitting up your services into smaller atomic units. But also even some of the larger monolithic services, the whole goal is that you're not pulling in the whole OS. You're just pulling in enough of the libraries and the binaries that are required to work. But because these are meant to be much more dynamic, that's where this is more amenable to microservices. And the microservices basically means that you're taking multi-function monolithic processing units and dividing it into individual units of processing. And this is where using Docker containers and as well as some of the orchestration engine, you can get the elasticity and dynamic behavior that you need to just deploy things up and down. So, and that's what you'll use. You'll see in past presentations at SMPTE as well, some of the usage for distribution and just serverless compute have actually used those type of environment, that type of microservices environment. So when we talk about microservices, microservices basically, if you split out the functions, they need to communicate with each other, right? So before, within a single app, it's okay, you could just make you had shared memory access, you could just call functions between each other. But now, if these are separate services, the messaging fabric becomes more important. Traditionally, you would just do API to API calls, and as you introduce new services, you basically make them talk to each other. You can have orchestration systems in the middle, of course, to make the APIs a little bit more decoupled. Another pattern is basically a message bus-based communication. So RabbitMQ is in one of the examples where these services, they may still be talking to each other, still be making API calls, but they're actually going through a message bus architecture. Right now, it's the message bus that's dealing with the resiliency issue of, like, say, a network goes down, messages being stored and then communicated across once everything comes up. But apart from the API to API calls, there's another aspect to it, which is the event-based event-based model. The event-based model basically says that you may not be making full API to API calls, but it may be things like completion events that you're triggering off, and other services are receiving them. And so you may have a transcode finished message, basically that's an event that gets triggered, and in response to that, just look at like service 4 and 5, both of them could receive the same event and do two different things completely. So that message bus architecture is coming out to be actually quite robust, and because it can be federated across multiple environments, it's actually finding a use there in some of the cloud hosting patterns here. So going across bare metal, data center, cloud, federation across, and again with secure connections and as well as security authentication across federation, you can start having services that were in one environment talk to another environment. Now, as far as the message bus is concerned, ideally, if you want to go towards microservices, it should talk microservices. But if it's talking through microservices, what happens with all of your traditional hardware-based appliances or any of the VM-based appliances, which you're not going to be refactoring or expecting the vendors to refactor into atomic microservices? They can still work because you can have connector microservices. These connector microservices are basically acting as a proxy for some of these monoliths. So as far as API calls are concerned, event handling is concerned, they're the ones that are receiving, but underneath they're talking to a lot of the software and hardware appliances. So using this method, it provides a federation mechanism across different hosting patterns, but it also accommodates the different virtualization methods that we talked about. And of course, if anything new has to be developed, you develop it through the microservices platform, but you bring along everything else together, so you don't lose your investment in the current products. We talked about the clients, creative tools. How do they connect together? So there are 4 different models here. Right? So, and again, depending on what type of work that you're doing, you may need to pick one or the other, or maybe multiple modes of this. So a web client, the most portable, right? You don't really need to install an application, and the HTML5 framework is getting so rich right now. There's full editing that's happening here, full playback. So it's getting quite rich, but of course it can be as rich still as a desktop client, right? So, certain functions can be done there, but you still need the desktop client experience, but still want to connect remotely. Mobile clients, same thing, again, using the same HTML5 framework or native OS frameworks, you can develop quite a bit and just, again, you can stream and use REST-based calls to actually get all of your information back and forth. The desktop application part is getting interesting because now there are two modes. As I mentioned, you're not going to give up your Surface controllers that are connected remotely. Or if you're in the field, if you want to ingest something locally, you need the USB connections. You need your dedicated connectivity to the client workstation. So for that, one client mode needs to be that the server is being accessed remotely, streamed, the media is being streamed as well. But then there's another pattern where you want to host the actual client application on the server side. So that gives you the same portability that the mobile client or the web client gives you, but it gives you the much richer experience of the full desktop client. But of course, today, you cannot have all the connectivity of all your controllers in there. So the PC over IP protocol and Microsoft's RDP protocol are coming along quite nicely on that front too. The speeds are improving, and the usability is actually improving, and we're making headway on that direction. But there's still choices to be made between all of these different modes. So putting it all together, clients on top, all the services, basically the federated message bus, going across multiple hosting environments, like I said, bare metal, VMs, cloud. You do need a platform that runs across. If you're just on a cloud, and as Gerald mentioned, if you're on an Azure public cloud or now on Azure Stack, part of that management software comes from the cloud provider themselves. But then when you go to bare metal and for certain other media services, like access management to certain media, roles, definition, you do need another part of another layer, which is more media savvy. And that's part of the platform, which actually does some of the resource management, service management execution, and identity access management, and also lets a lot of the client applications connect together with this platform. Right, so this is sort of the total picture that we're drawing over here, which is what lets you go from public cloud, bare metal, data center. It eases that transition. And just to follow up on what Gerald had mentioned about Azure Stack, so first of all, just on public Azure, we've been doing a lot of demonstrations, and not just demonstrations, but there have been quite a lot of media enterprises who have tested out a full stack editing experience, asset management experience on the Azure public cloud. At IBC, we actually had another showing of Azure Stack, an on-premises Azure Stack, working together with the public cloud Azure Stack. So again, we actually paired up with a large news provider, and we had some of the newsroom management system using the web client, a media asset management for archive, all of these services running on the private stack, on the Azure Stack, but yet it was actually working with the public cloud for any of the Azure Media Analytics and those type of services. So this was basically the talk, and just to summarize, as I mentioned before, when we go to media clients, when they say that they want to go to the cloud, we literally do have to hone in a little bit more just to ask about what type of segment are they addressing, what type of work they're doing, and then define which. It's a bit subtle between all the cloud definitions, but we do have to get to that level just to make it practical. And then even as you're planning a transition, you do need to take care of what's the state of which virtualization technology is appropriate, what does the different infrastructure providers provide in terms of abstractions, geographical network proximity for storage, and low latency operations. These become factors. And to ease that transition is where some of the software platforms come in that allow you to bridge between these hosting patterns and allow you to move towards this whole public cloud and private cloud joint operation. So that's our talk. We have 2 minutes.
Microphone? Thank you. So if you have a question for either of them, you can stand up. I have a question. If I'm running, let's say I'm running a color corrector, and it's 4K, it's local, I get the best possible quality imaginable. Now I'm going to put it in the cloud, I'm going to use PC over IP and say, I'm still going to do color correction. Mm-hmm. What sacrifice in quality do I give? And how do you prove that it's good enough for people to do their work?
Yeah, for today, right now, actually, I'm mic'd up. So So this is where the PC over IP, RDP, and some of these protocols are still evolving. So you can do high resolution, but on still images, for example, right? But when it comes, and you can do multiple monitors, that type of stuff, 8-bit versus 10-bit, there are differences. There's compression involved in all of this, but slowly these are changing as well. So there are certain sacrifices today, but it doesn't mean you can't do all of this work, because there are certain pieces of work that you can do which may not be full color corrections yet, but some of the collaboration, color management, and other aspects of it. But remoting display today, this is still evolving. So there are certain use cases that work really well. Certain use cases, we're still working on the technology stack for that.
Michael Cutter.
Hey, thanks for the intro. Are you guys doing anything to try to push the PC over IP stuff a little faster? Like multi-channel audio beyond stereo has been an issue with that in the past?
Yeah, so multi-channel audio. So some of these things are actually with the vendors who develop PC over IP, and that's why some of the Microsoft guys with RDP. So there are certain discussions going on. One other area that should be now looked at and is proving to be promises, and again, this is all around IP, right? So maybe bypassing some of that whole remote display protocol and start focusing perhaps on some of these IP protocols, which our on-premises devices are already adopting, so that can start forming the alternative. And by the way, that may form the answer for the color correction cases as well, where the broadcast monitoring may be actually happening through those type of environments. But answer is yes, there are ideas of how to improve all of those, the PC over IP experience, but those are still being worked through.
Do I have time for one more?
Yeah. Actually, we're out of time, but you know all about time. You're a timeline guy. Thank you very much.
Thank you.